Welcome to a re-intro to improper integrals. So recall improper integrals are definite integrals. Which don't meet the conditions for the fundamental theorem of calculus. So there were essentially two ways that the fundamental theorem of calculus could fail. Option one could be that the function, the integrand, is discontinuous. And in particular, we're going to look at the case where it's unbounded. So typically that will appear as a vertical asymptote. The other case could be that the bounds of the definite integral are themselves infinite. And because the fundamental theorem of calculus required our function to be continuous over the entire closed interval between the two bounds. If the bounds are infinite, we no longer have a closed interval. So the standard forms for improper integrals, we could have a first case would be, let's do with infinite bounds. So we could have an integral that goes from a to infinity of f of x dx. I apologize, let me update my screen. And here we have an integral from a to infinity, f of x dx. Another one with infinite bounds would be an integral from negative infinity to b of f of x dx. And then we could also have both bounds being infinite, in which case we would go from negative infinity to positive infinity of f of x dx. So these are our cases where we have infinite bounds. And then the other case we could have is we could have a definite integral from a to b of f of x dx, where f has a vertical asymptote at x equals c for some c between a and b. C can be one of the endpoints. It could be that the vertical asymptote is at one of the endpoints, or it could be that the vertical asymptote is somewhere in between. So in the next couple of videos, we're going to focus on the case where we have infinite bounds. And then we will move into what we do when we have our vertical asymptote, when our function f is unbounded. All right.